For the statement 1, in order to check whether the summation of n equals to 1 to infinity of 1 over n square converges or not, we are going to use this p-series test. So p-series test goes something like this. So whenever I have any series, which is 1 to infinity, if I have 1 over n to the power of p, and if p is greater than 1, it converges. And here clearly in place of p we have 2, so that's why this one would converge. If I talk about statement 2, and here clearly the statement 2 is an harmonic series. So whenever in a p series, if p is equals to 1, so we call that one as a harmonic series, and harmonic series would diverge. So that's why the statement 2 will not converge. So this is basically getting converged, and this will not converge. And for the third part, so we have to use this alternating series. Alternating series test. So the alternating series test goes something like this. So here, whenever I have summation of n equals to 1 to infinity, whenever a power n, where a power n can be written as minus 1 power n into b power n, then we can just check it for b power n. Is b power n in this case is going to be 1 over square root of n. So whether this one converges or not. So if I want to check this, so I have the summation of n equals to 1 to infinity of 1 over n to the power of half. Now, in order to check this, we don't have to check it with the p series. So what we have to do is, we need to check this whether the limit n tends to infinity of whether this b power n is 0 or not. Yes, that is 0, because if I talk about limit n tends to infinity of 1 over square root of n, so 1 over infinity would be just 0. So this is true. And also b of n is a decreasing sequence or decreasing series. So that's the reason your a of n would also converge. So that's the reason option D is the right answer for this sum.